Welcome back to the Build Day Live with Supermicro. We're going to take a look at the actual hardware of the BigTwin that we've been building today. And joining me to go over that is Bill Chen. Welcome, Bill. And can you tell us a little bit about what your role here is at Supermicro?
I'm the senior product director in the server department, and BigTwin, the Twin family, is my major product here.
And it's one of the biggest selling products for,
That's right.
for the company.
BigTwin is our major product in the Scalable platform.
Great. And this is the, what was, when I first saw it, revolutionary 4 servers in 2U form factor. Run us through a little bit how it's different from a rack mount server and how it's different from a blade enclosure.
Okay, I think we can talk about the Twin family back in about year 2007. We designed the first 1U 2-node system we call Twin family. We start from that, and then we got very good feedback from customer side, and then we start to design a 2U 4-node system. So we call Twin Pro, and we also have very good result on the Twin Pro. And after that, once go to the Scalable platform, we found there's some bottleneck there because in this form factor, we have a limitation on memory design, memory population, right? So at that time, we try to see how can we put in 24 DIMM in this form factor. So that's the reason we come out with BigTwin solution. And the key factor is that we have the special power supply design we call power stick. And this power stick design can let us to have more space on the motherboard. So you can see the so skinny, this is only 38 millimeter width compared to a regular power supply is only half of this width. So that's the reason we can have more space on the motherboard to support a 24 DIMM memory.
So that's extra width to have the extra banks of DIMMs either side of the CPU
right.
sockets, because you're very constrained about how you can lay things out when you've got a very long, thin platform in here.
Yeah, that's why compared to the other solution, that this one can support more feature. That we call it no compromise any feature compared to the rack mount server. So in the rack mount server, normally you can see that you can put a 2DIMM CPU, 24 DIMM memory, a lot of expansion slot, and I/O. So in this 2U 4-node system, we did not compromise any feature compared to a 1U rack mount server.
Yeah, you get the same functionality in each node as a 1U rack mount server.
That's right.
But you get 4 of them in 2U. And you get simpler cabling to a certain extent because you're only running 2 power supplies.
Yeah, so we run 2 power supplies, and that's the key, right? This power supply, we support up to 2200 watt, and also we have a 2600 watt version for customers if they want to have a higher bit of CPU, or you want to fully populate memory. Right. We also have a 2600 watt power supply. So share with the 4 computing node, so that you can have a more power saving, have a better power efficiency. Right? So and also this is 1+1 redundant power supply. So even one power supply is failed, the 4 nodes still continue to run. Power. Correct.
That's great, and yeah, fits very nicely with a dual PDU rack deployment. Can we take a look at that node that we've got eased out? Sure. Because of course, 4 nodes, well, there's 4 of these servers, so that's the equivalent of a 1U rack mount server and in there.
We use a 0.5U space.
Right. So half width, 1U height. And so standard 1U type heat sinks in there, although I imagine there's a fair amount of engineering of your own done to it, because there's actually a pipe through the middle of this one that is clear so that some cold air hits the heatsink for the rear CPU. So there's some really interesting engineering going on in there.
Yeah, so here you can see that we have the a pipe to direct the hot or cold air to the back end side. So normally the 2 CPU front and back, you have about 10 degree
differential.
Yeah. And so that's why we have this design to balance that. Right? So that's good for cooling. And then we have a 24 DIMM. You can see that all 24 DIMM can be populated.
Yeah, and in the lab, we don't need that much memory, and it costs a lot of money to fully populate them. If you're not going to use it, you don't need to.
But you know, for the 24 DIMM design, is one benefit that normally customers they have some configuration say that they need a 512 gigabyte memory, and in that case, you normally will put a 16 DIMM or 32G, right? Yeah. And right now, compare the pricing, 32G and 64 gigabyte memory, 32G still have a sweet spot there, right?
Yeah.
So we can put in the 8 DIMM per CPU you still can get a balanced mode of a memory.
Mm-hmm.
But if you use a 16 DIMM design of the motherboard, then you need to fully populate the 16 DIMM. That will be unbalanced design because you have a 6-channel per CPU. In that design, the balance mode is unbalanced. So with this 24 DIMM design, you can have first the better pricing, and also you still get a better performance.
More consistent performance with the balanced memory config.
Yeah.
And then there's some other really cool pieces in here. One of the ones that I hadn't heard before you told me about it, Bill, was this plug-in module here that gives us an option to boot from some pretty cool media without consuming any of the storage in the front of this thing.
That's right. So for the storage supporting, right? So we use this we call adapter board to direct the signal from the motherboard to the front side, right? Front side we support each node can support up to 6 devices. It can be NVMe, SAS, SATA, right? You can count tri-mode. You can, based on customer requirement or application, you can select different device. Yeah. And other than the storage, 6 devices in the front, we have one adapter board here to support to M.2. And this M.2 can be either SATA or NVMe. And normally, the most application using these to load the OS or put a hypervisor in this location. So you don't need to sacrifice any space in the front side of the house.
But I can have enterprise-grade storage for the operating system.
Correct.
And then not compromise on the 6 storage devices for my actual application data in the front.
Yeah, and the good thing that we have a 2 M.2 can be support, and you can build a RAID 1 to mirroring. So that can have
single media failure doesn't take the system down.
That's right.
Now, we're not using that in this lab for this vSAN build. We're using this other guy. That's the SATA DOM plugged in here. So it's a small SSD on a little card that plugs directly into the SATA port. Personally, I love these for booting ESXi servers because they're way more reliable and better performance than a USB key. But they're not taking up any slots that I could put storage for VMs. I definitely want different separate boot media for my ESXi server from my storage, and the SATA DOMs are really good for that.
Yeah, so that's the reason we put a SATA DOM and an M.2 option for customers to do to have their own selection.
And that the ability to choose different things and have them work at a really good level is one of the features that we see throughout the Supermicro. And I particularly have seen it this week with the modular. It's not really a LAN on motherboard, but it fulfills the function that other vendors provide by putting a network adapter on the motherboard. You have a modular network adapter that plugs into the motherboard. Can you talk us a little bit about that?
So this device we call Supermicro I/O module, SIOM, right? So you can see that that's kind of like cut off the motherboard portion of a motherboard. So normally you put a network controller down to the motherboard, but however, in this moment, so many different networking solutions. You have a 1G, 10G, even 10G you have a base T or 10G SP+, and 25G, 50G, 100G, and InfiniBand. So many different solutions. So that's why we have this kind of design to let customers to select what kind of networking they are looking for. So they can have a flexible networking, and you don't need to occupy any expansion slot.
It uses the CPU's built-in support for networking rather than using PCI Express. Okay. But of course, you can use PCI Express because we have a couple of slots here, a couple of 16 times slots in the back. Yeah,
so other than the SIM slot, we also have 2 PCIe by 16 Gen 3 slots. So some customers, they not satisfied with only one card with a 4-port only. They need to have a redundancy. So you need to plug in the other networking card. SIM card is from CPU 1, and you can plug in the other card from CPU 2. So we can have a kind of balance networking.
Balance of the PCI buses. Yeah, nice. And I could put fiber channel cards or something else in there for whatever my needs were.
So many different solutions.
And presumably I could pass out PCIe to go to a JBOF or some other PCIe fabric as well.
That's right.
Right. Now, the other element that we're showing in this build is using Intel Optane storage. And this is the high bandwidth, low latency, ridiculous transactional performance that you get out of the Intel Optane hardware. This is providing us in the VSAN configuration. A couple of these are providing the cache tier, and we've got some 4 terabyte conventional NAND flash drives for capacity. So these are really cool and provide incredibly low latency and high transaction rates, and of course they're NVMe, so there's lots of queues, and that helps also utilize the low latency of the storage. So I'm quite pleased to have these in. I've not had any experience with Optane before. How does Optane fit in the product set for Supermicro?
So Optane, we start from the beginning. We do the Optane testing for a while already.
So it's really the next generation of flash storage is moving towards these really low latency platforms. I mean, they're what's driving NVMe as a technology, is having these low latency, high bandwidth platforms to attach to something. If you attach them to a SATA bus or a SAS bus, that you're just not going to get the benefits of them. So yeah, nice to have these devices in here. And of course, NVMe isn't the only option to have on the front. For those who haven't looked at NVMe, it's PCI Express being sent all the way down to this U.2 device. There are other options for connecting storage to the front of these guys, those 6 storage devices that go to each node. What are our other options if I'm not going to spend all of the money on the fastest thing you can buy today?
Yeah, so we have a six hot-swap in the front side. You can have a NVMe or a SAS or a SATA, or it's kind of tri-mode backplane. You can, based on the model you select, you can have a different storage solution. So normally we have a customer that using Optane, for example, Optane for the caching, and for 2 drive for caching, and the other 4 drive you can put the data, because Optane you can use in caching for more lower latency and higher bandwidth.
Yeah, and it also has a much higher write endurance.
That's right.
Than the NAND flash, so it's really good as a cache tier. And then in the lab we're using 4 terabyte SSDs in the other 4 slots, but there are 8 and 16 terabyte options on the market.
So I think to talk about the NVMe, other than the internal storage, we have a 6 NVMe. Like you mentioned about the JBOD, right? But actually, we have the other solution for the JBOD. We can use a BigTwin 4-node connect to the outside. We have a 1U JBOD, can support a 36 NVMe in a 1U platform. So with a 2U BigTwin plus 1U JBOD, total we can have a 16 plus the 36. We have a 52 NVMe device in the 4-node system. So other than the internal 6 drive, you can have the other 8 drive.
A lot more attached outside. Yeah,
that's right.
Nice. That would be a ridiculously large amount of storage performance, and I guess to handle that amount of NVMe storage, you're going to need to use something like the Intel Scalable CPUs. You're not going to be wanting to use some of the lower core count, because you simply won't get the throughput with a very low core count.
Yeah.
Nice. Well, thank you very much, Bill, for joining us here. And thank you for joining us in the video, and we hope you'll stay tuned for more Build Day Live videos here at Supermicro.
Thank you.